Hello, I'm Samana Shrestha. I'm going to give a short lecture on static friction today. So before I start static friction, I should tell you what friction is. So friction is basically the opposing force that comes into play whenever one body slides or tend to slide or roll over the other. So this friction being path dependent, so whenever there is a frictional force, there is a loss of energy in the form of heat. So frictional force is a non-conservative force. So say there are two bodies which are in contact with each other. Though these surfaces seem smooth, there are so many irregularities and projections in between these two. And when I apply a force from this direction, these irregularities, projections get interlocked with each other. So even if I apply the force, one cannot slide on the other. That means there is this opposing force here is called as the frictional force. There are so many examples of. Basically, I will focus more on static friction in today's lecture. So the examples in the real world are say this sitting here on top of this one. It is stationary. A pile of books, the books being stacked, the cars on the road, and etc. are some examples of static friction. So to reduce friction, there are many methods, like we use lubricating agents like oil, grease. We use the ball bearings because the rolling friction is less than the kinetic friction, is less than the static friction, which I will be explaining now. Again, let's say I'm applying an external force of Fe here, but it doesn't move. It's not moving because the opposing force here, the static friction is opposing here to move the body on top of other. I'm explaining this by a graph here. Say this is the external force I have applied and this is the frictional force. So with the increase in the external force, the frictional force increases. I apply more force, the frictional force increases more, and so on, and so on, so on. So as the external force increases, the frictional force keeps on increasing and becomes maximum. This maximum friction is called as the static friction. Now beyond that point, if I apply more force, now the friction quickly drops, and the body begins to slide down, and this dropped friction here is the kinetic friction. Now with a slight more force, the body moves, whereas this friction, which is the kinetic friction, is constant now. It is constant. So this is a body of mass m, and the forces being acted here are one in vertically downward direction due to its weight mz, where z is the gravity. The other is the normal reaction r in vertically upward direction. This body being on horizontal surface, this r and mz are equal and opposite. They cancel with each other. That is why this body doesn't move up or down. However, depending on the external force, how much I have applied, and the frictional force in the opposite direction, this is the external force applied and this is the frictional force, the body moves towards left or towards right. From here we could see that static friction is more than the kinetic friction. Now, this frictional force, which is in the direction opposite to applied force, depends on the normal reaction r. So removing this proportionality sign, we get a proportionality constant mu, where this mu is a proportionality constant, which is a dimensionless quantity because it is the ratio of two forces in Newton, the externally applied force and the normal reaction, which is also a force. So this coefficient of friction is a dimensionless quantity. In case of static friction, that means whenever the body is not moving, the frictional force being applied here is the static friction, and this static friction is equal to the product of the coefficient of static friction and the normal reaction r. Whereas if this force Fe is enough to overcome Fs, this slides, and the frictional force that comes into play is the kinetic friction, which is less than the static friction. Now in that case, the kinetic friction is the product of mu k and r, where mu k is the coefficient of kinetic friction. So from here and here, still we can say that coefficient of static friction is greater than the coefficient of kinetic friction. Now let me explain this example, giving some numbers. Say the mass of the body is 5 kilogram. the mass of the body is 5 kilogram. So the force in vertically downward direction is mass is 5 and g being gravity. Let's take z. The actual value of z is 9.8, but we take here to be 10 for our calculation to be easy. So in vertically downward direction, the force due to its weight is m times z. 5 times 10 is 50 newtons. So the static friction Fs here is mu s is mu s is 0.4 and mu k is 0.3 because mu s is more than mu k. So Fs is mu s times r. Mu s is 0.4 and our normal reaction R, which is equal to mg, and mg is 5 times 10 is 50 times 50. 0.4 times 50 is 20 Newton. Similarly, for the kinetic friction, Fk equals to mu k times R, and mu k is 0.3 times 50 times 15 Newton. Now we see the coefficient, the static friction is 20 Newton and the kinetic friction is 15 Newton. So if I apply a force of 10 Newton, which is less than 20 Newton, so this body is stationary, it doesn't move, it's not accelerated, and the friction that comes into play here is the static friction. However, if I increase the force from 10 Newton, say 12 to 14, 14 to 16, 16 to 18, which is still less than the opposing force, so still it will not move. However, the static friction is increasing, the external force is also increasing. Now, as the external force applied is 20 Newton, which is just enough to slide this one. So beyond that, if I increase the external force more than 20, now the friction quickly drops and the body slides. The quickly drop friction here is the kinetic friction, which is less than 20, which is 15. Say I apply an external force of 25 Newton. So this 25 Newton is enough to overcome the sliding friction, the static friction, so it is enough for this body to slide, whereas the kinetic friction is 15 Newton. So the difference between these two forces, 25 and 15 Newton, is 10 Newton. So this net force, which is towards right, towards the direction of maximum force, so that force is enough to accelerate the body now. And the net force being acted here is the difference between these two forces, which is 10, and mass is 5 times, these are the directions, A, so acceleration is 2 meters per second square. So I can say by the application of 25 Newton of force, 25 Newton of force would be sufficient enough to accelerate this body by 2 meters per second square along the direction of the force applied, because it's more than the kinetic friction. Yeah, I think with this example I could make static friction, like I could explain static friction clearly. Thank you.